Okay, going to show you how to work in vectors in 2 dimensions here. That means they're coplanar. It means they're on the same plane. So, for instance, these vectors are on the same board. That means they're on the same plane. This one, we're given 3 and 4, and we can work out the magnitude of the resultant vector just by using a bit of Pythagoras. You may recognise that. That's a 3, 4, 5 Pythagorean triple. You've done that loads of times, so I'm sure you've got that skill. If you're given the angle and you're given the magnitude, if you're given the other two and you need to work out the angle, then you use a bit of trig. And I'm not going to recommend that you do this over and over again, but just to show you, remember you get secatoa out, then you're using the adj and the op you've been given, the adjacent next to the angle, opposite across from the angle, therefore tan of the angle is the opposite over the adjacent, so the angle theta is tan to the -1, the opposite by the adjacent, just put them in brackets. Okay, well sometimes you might be given a vector on an angle, here's vector v with angle theta to the horizontal, and asked to resolve it into the horizontal component and the vertical component here. So firstly, the vector v in the x direction. Again, simple bit of trig really. Cosine of theta is vx, v in the x dimension, divided by v. So rearrange that to vx equals v cos theta. And down here, we're trying to get the v in the y dimension. So that means you're going to use the opposite, because really, although I've drawn it here, it's like saying it's a right angle triangle with it here where these blue dots are, which is the opposite, and you know the hypotenuse is v. So sine of theta is the v in the y direction divided by v itself. So vy is v sine theta. And Mr. Elmore in his video gave you a trick to remembering this. Think, if you're closing the angle, you use cos. If you're swinging the angle open, you use sine. So here, we're closing the angle down to get the horizontal, and here we're swinging the angle open, so we use sine. I hope that makes sense to you. One last thing then, if you're given 2 vectors and they're not at right angles, you can work through some algebra, but you're not expected to at this level. You can actually use something called scale drawing. So here I've drawn with a ruler 4 meters per second, that's represented by 4 centimeters. Here 5 meters per second, represented by 5 centimeters. But that's at an angle 20 degrees. So I can't just add them together because they're not in one dimension. So I need to use a scale drawing. And what I do, I just remember to combine the vectors top to toe. So I draw out the 4 centimeter one, 4 meters per second one, and then with a protractor add the next one on from its toe at the top of the last arrow. And the red, therefore, the red arrow there is the resultant vector. And I measured that with a ruler, it's 9.2 centimeters, so it's 9.2 meters per second. And I measured the angle with a protractor, and that was 11 degrees. So that should be pretty easy. Just remember, scale drawing, you need to combine the vectors top to toe. And, well, you're going to need those 2 things, aren't you? And a pencil for your exam. I hope that helped. Please like it, share it, and subscribe.